Hey everyone, this is Professor Surge. This is the tutorial on systems of linear inequalities. If you hadn't already seen it yet, I'd recommend you go and have a look at my other tutorial, Linear Inequalities, without the systems. If you're familiar with inequalities and graphing inequalities, then you'll recognize right away that I have two listed here. That's because now we're graphing a system of inequalities. And what that means is that instead of just one of these functions, y is less than or equal to 5, for example, governing which values on the graph are going to be valid, both of these functions are going to do it simultaneously. So to start this, we're going to graph them just like we would for a regular linear inequality. Let's start with y is less than or equal to 5. So the first thing you notice is that it's less than or equal to. That means we're going to draw a solid line as the boundary. And the boundary is going to be at y equals 5. So we have 1, 2, 3, 4, 5 right here. I'm going to draw my solid line through 5. That's going through 5, not 6. And that line is y equals 5. That's the boundary. Less than or equal to 5. That means that we're going to shade the values underneath the function, everything that's less than or equal to 5. And you can verify this by just picking a point on the graph. Let's say 0, 0. So if we verify this with the point 0, 0, we'll see 0 is less than or equal to 5. That's true. And so we rightfully shaded this bottom half here. Now we're going to graph the next inequality. I'll do this in a different color just so it's a little bit easier to see. There's going to be a lot going on in this graph. Y is greater than 2x plus 1. Right away you should notice the greater than is going to imply that we're going to draw a dotted line. And so my boundary for the inequality is going to be y equals 2x plus 1. Let me draw y equals 2x plus 1. You can draw this just like any other equation that you would graph. And the way I'm going to do it is I see that this is in y equals mx plus b form, slope-intercept form. B is where my line is going to intersect the y-axis, and that's at 1. So at y equals 1, we're going to intersect the y-axis. And then I have a slope of 2x. So for every 2y that increases, I'm going to increase 1x, or vice versa. For every 1 increase in x, I'm going to increase 2y. So there's my dotted line, roughly. So this is the boundary for the inequality. Y is greater than 2x plus 1, and the boundary is equal to 2x plus 1. And now I'll simply shade in all the coordinates and all the area that satisfies this inequality. And because it's y is greater than 2x plus 1, greater than implies that it's going to be above this line. We could also use a test point. So let's see a test point here. How about right here? That would be x is equal to 0, y is equal to 5. So at 0, 5, it's going to be 5 is greater than 2 times 0 plus 1, or 5 is greater than 1. That's true, and so I shaded the correct area. Now this is where we get to the systems part. We graphed both inequalities independently at this point, but on the same Cartesian plane. And you'll notice that there's a section, which I'll shade it in green here, where both functions, the shading from both functions overlap. This region is the region that satisfies both inequalities. And what we can do here is we can pick a point on the graph that falls into the region with where both are shaded. And I'll draw that here in dark green so you can see. And that point is x equals -5, y equals 0. Now I take my original inequalities, I take both of them, y is less than or equal to 5, and y is greater than 2x plus 1. And I plug this point into both of the inequalities. So I'll have 0 is less than or equal to 5, which is true, and 0 is greater than 2 times -5 plus 1. 2 times -5 is -10, plus 1 is -9. So 0 is greater than -9. Of course, 0 is greater than any negative number, so this is also true. This graph allows me to visually inspect the overlap on these two functions. And it doesn't just have to be two functions. It could be one function like we did in the linear, graphing linear inequalities tutorial, or it could be an infinite number of functions, as many as we need. And what do we mean by need? What would we need to do this for besides just what the book tells us to do or what our math teacher assigns us for homework? Well, you can think of the variables as real life things. For example, maybe y is the height of a box, and x are goods that we're trying to put into the box. Maybe they're oranges. So we're trying to figure out how big our box needs to be, or how tall our box needs to be, to fit in x oranges. And we've decided there's some constraints here. Maybe the height has to be less than or equal to 5, the height of the box, because if it's too tall, it won't fit on a shelf in the store. So that's what this horizontal graph would represent. And maybe our red graph represents the size of the box that we need to be able to fit the oranges. So the height of the box has to be greater than 2x plus 1, otherwise the oranges just don't fit. So what we've done is we've found visually this little area right here. See that triangle? That's the area that represents the kind of boxes that we can have to store our oranges. And why did I only shade in this little sliver here and not the entire overlap region? Well, because you can't have negative oranges, and everything to the left of the y-axis is negative oranges. That just doesn't make any sense. So you gotta use your common sense a little too. There is one more interesting thing about systems of inequalities I want to show you. And that is that I could have two inequalities. Let's say y is greater than 2x plus 1 and y is less than 2x minus 1. So if we graph these, we'll do it real quick. The first one is 2x plus 1. So that's our intercept at plus 1. And it's going to be approximately sloping like this. Of course, I drew a solid line, so let me just make this solid line to be easier. So greater than or equal implies a solid line. And then if I draw my other line, y is less than or equal to 2x plus 1, 2x minus 1, my intercept is at negative 1, and the graph is parallel. The line is parallel. So for this one, I shade underneath, y is less than 2x minus 1, and this one is greater than 2x plus 1, so I shade above. And what we see is there's actually no solution for this system because there's no area of overlap, and visually this is very simple to see. And that's all there is to it. Now you can graph anything.